Welcome back to Electronic Projects. In this video we'll talk about LDR, and again this video is intended for school students and new electronic beginners. I just want to explain the concept. The idea is not the project building of nightlight. This is something to make you guys understand how an LDR works in conjunction with the transistor. So we'll go to the basic symbol of LDR. LDR is nothing but a light dependent resistor. So the resistance varies according to the light falling on it. This is the basic symbol of an LDR component. And for those who have not seen, LDR will look something like this. Hope you can see it. So this is the basic LDR. Let me zoom in a bit. Hope you guys can see it properly. Here you go. This is LDR, and it comes in various sizes and types, and there are big and small, and this is the basic symbol of LDR. In analogy, if I want to explain more, the LDR this is a resistance, and the resistance will decrease if light is more. And the resistance will increase. It will be in the order of only ohms when there is more light, and the resistance will increase if it's dark, and it will be in the order of mega ohms when there is no light at all. And as a simple analogy, we can this, if you stay, for example, if you have more light here, this can be equated to water flowing through a pipe. That's how we usually that's how we use to represent the resistors. Say for example, if you have more light, if you have more light on the LDR, the resistance is going to be less. When you have more light, this LDR will be similar or equal to a pipe with a little bend on it. This portion you can call it as a resistance, and you have more voltage if in case of a wire, more water flow if in case of pipe. This is how it will be in more light. So what happens if your light is becoming less? What happens if your light is reducing a bit? So when your light is reducing a bit, what happens is that when your light reduces, simultaneously your resistivity start building up. So it will be something like this. If your amount of light is reduced, in less light, the bend will be like this. The resistance will start building up, narrowing the pipe, and you will have little water flow, little flow of voltage across this. And what happens if it is getting darker, even darker? If you have no light at all, then this resistance keep increasing more instantly, and you will have like very less pathway, and your flow of water, flow of electron in case of wire will be like very negligible, because it will be in order of mega ohms. When it is in order of mega ohms, the resistance is too high, and it's like hardly getting, the voltage will hardly get in here. This is how a normal LDR works, and the LDR comes in different sizes and combinations. based on the industrial standard, and basically this LDR concept is used in street lights, wherein when the light falls out and when dark creeps in, the light automatically switches on and you don't have to deploy a person to flick the light on. And we will see a basic circuitry for night light. Before that, I want to show you guys how the LDR reacts to an ambient light. That way you guys can have a more understanding of what I was saying before. So this is our breadboard. Hope you guys can see a breadboard, and this is our LDR, and I'm going to hook this LDR into the breadboard, and we will flick our multimeter to ohms in automatic mode, and then we will connect the two leads of the LDR. You can connect any lead. It is a resistor, it doesn't have polarity. And once I connect, I'll show you the resistance. It will be in the order of ohms. So if you can see, it's an order of 837 ohms, and this is because today is cloudy and we don't have ambient light as such. It's like a very cloudy day, and if you shed some light on it, this resistance will go away. If you shed some light on it, I have a torch with me. The moment I blow the torch on the face of the LDR, it's going to reduce. You can see it's reducing considerably, like an order of 100 ohms, 90 ohms, 94 ohms. It's coming back to 99 ohms. So when I move the torch away, it creeps into ambient light intensity, that's 800 ohms. And say for example, if I have a cap and I'm going to block the face of this LDR, and you can see the resistance will increase considerably, as I told you before. So if I'm blocking the light, see it has jumped into kilo ohms, and if I'm blacking it completely, and it keeps on increasing, and if I'm covering the base of this so that the straight light doesn't go away, so it jumps into like almost like open loop, like it doesn't want to allow anything. So if I take it away, you can see it drops down to mega ohm and then into kilo ohm for the straight light to get in. And if I take this cap away, it comes back to ohms. So this is how it basically works, and this is the nature of the LDR, and we can utilize this to very well to build a simple circuit to do a night light, which automatically powers up an LED in our case when the light falls off. And in street lights, they utilize a relay to drive high circuitry, a high halogen lamp as such. So now we will see the circuit, how the circuit will look like. We will deploy a basic transistor BC547. I'll show you guys the pinout as well. So our circuit is very simple. This is the LDR, and this is 33 kilo ohm resistor. This acts as a voltage divider circuit. This is 9 volt or 5 volt depending on what load you are going to put in. You can put much load. If you want to put much load, you have to put a relay in between. I will tell you guys what a relay is and the fundamentals of relay in coming videos. And this is normal NPN transistors, and this is emitter, this is ground, and this is collector, and this is base. And we we will put a small LED. This is an LED, and this should be like 390 ohms. We have seen an resistance and LED combination to protect the LED. Same thing goes in here, and this is ground. So this is an LDR, and this base, and this is BC547 transistors, and the pinout for the BC547 transistor is something like this. You can always check in the database or data sheet BC547, and the D will go at the back. This is the front end where you have the writings on it, and you will have 3 pins here. Pardon me, my diagram is not that great. You can do much better than me. This is collector, this is base, and this is emitter. This is how a BC547 looks like. So in normal circumstances, let's see what's happening, how this LED is driving will lit on when there is a voltage, when there is a light falling, how it works, like how it normally operates. So in normal circumstances, okay, when there is ambient light, when there is more light, what happens is that when there is when there is more light, say for example, I am just adding an arrow mark so that you guys can understand. When there is sufficient light, the resistance will be very less. In that case, what happens, the voltage always, it's like a flow of water, it always flows through a least resistive path. So the voltage will come in all the way here, it will be already there live, and it will pass through this 33 kilo ohm resistor, and it won't go here, it will not go here. Instead it will take the least resistant part, and for the voltage going through here and getting grounded is the least resistant part rather than going this way, because the forward bias voltage and the resistive path is more for this one. So this will be in order of ohms, and when there is more light, and this voltage will go all the way to the ground. So because this is having less resistance, and the voltage will follow this rather than going here, it will not go here. So I put a cross mark here when there is more light. And when there is less light, what happens? When there is no light, or when there is darkness, what happens is that this will be in the order of mega ohms. This will be in the order of mega ohms, okay? This will be in the order of mega ohms. So the resistance is too high, or the pathway will be too narrow for the voltage to flow in. So when the pathway is too narrow, the voltage, what it does is that it comes in all the way here, and then there is no path for me to go in. So what I do, I will take the least resistive path. Now the least resistive path is through the base emitter junction, so the voltage will flow here. If there is no light, gentlemen, the voltage will flow here through the base, and then when it gets into the base, as you know before, the transistor works like a switch, not exactly like a switch. As the voltage increases, the conductivity between the collector and the emitter increases for an NPN transistor. So when the voltage gets into the base here, the collector and the emitter gets in contact, and when it gets in contact, the LED will find a pathway for the voltage to come in across it and get into the ground. In this way, the LED will start lighting up. What if you want to drive a high circuitry, you need to implement a relay. Relay in the sense, it's a 2-contact device that we will see it in an upcoming video. For basic understanding, we will try to build this circuitry, and we will see how it's working. Yeah. Now it's breadboard time. We will see it in operation. We will see the circuitry in operation. Now that we have seen the circuit operations and the nature of the LDI in the whiteboard, now we will build a little circuit and for this I'm using a BC547 transistor, the base of the circuit. So I'll just build this up quickly for you so that you guys can finish off watching this video. And let's hook up this LED here. So this is just to drive a simple circuitry, and if you want to drive a bigger circuitry, you guys need to have a relay. And this is like 390 ohms resistors. I don't know if you guys can see or not. Yeah, it's 390 ohm resistors. And then just hook this up. So 390 ohm resistors come to the LED and then goes to the base of this transistor. That portion is finished. Now we need to put a 47 kilo ohm resistor, and then to the power supply, and then we'll put LDR. We'll put an LDR, hook it in properly, hook it on properly. And this is 47 kilo ohm coming from the source and gets connected, and in between we have to connect the base of the transistors, and the LDR goes to the ground emitter. So this is the emitter. It has gone to the emitter, and the base has come to the center, and then the circuit is complete. So this is it. So what we are going to do is that we are going to give a supply. The supply here, 5 volt supply. Put a positive to positive terminal. Negative to negative terminal. So now, since we have ambient light, this LED will not glow. So in this case, what I'm going to do is that I'm going to use this cap. And then we will blank out this LDR. And then when the moment I will start blanking out, the resistance goes high, and the voltage will follow this 33K, and then it get bypassed to the base, activating this transistor and lighting up this LED. Let's see about that. I'm just taking the cap slowly, and see the moment I just put it in, the LED goes in. You can see it's coming on again, and the moment I take this away, it goes off. This is how it works. Like, so in ambient light, the LED stays off, and when it's getting darker, the LED gets activated. This is what they use for street light switching purposes, automatic street light. No one is deployed to switch on your street lights. It will have this little circuitry with the apparently with a big LDR, industrial grade LDR, and with a relay. Instead of LED, in place of LED, they will have a relay to activate a mechanical switch so that it can give high power and high voltage to the lamp that is in the streets. So this is it, gentlemen. This is the circuitry for night light activated. You can see it's hardly going to cost you a few cents of components, but it can do a great job. About the relay and the functionality of the relay, I'll tell you guys in detail in the next video. And this is all about the night light activation. And as soon as you blank your light off, your LED will go in. And you can put in if you have a bigger transistor, you can put in a bigger load. And if you want a heavy load like to drive 240 volts, then you can go for a relay. See, even if you blank it from and then it comes. See that? Yeah. So this is it. And thanks for watching. If you like my videos, please do like and comment for me to improve my videos. that's just a loose contact. If you like my video, again I'm saying, if you like my video, please do like and comment and subscribe, and thanks for watching again. Thank you very much. We'll see you soon.